welcome back to Physics Lesson with me, Pratama. We will still talking about the kinematics, but this time we are going to talk about accelerated motion. It means that the equations that we are going to use will involve accelerations. So I will give you the derivations of this kinematics formula in this video. In this video, I will talk about the equation of motion. I'll show you how to derive all four equations, then go over some important points to remember. Sometimes these are referred to as the SUV equations because of the letters we use. S is displacement, U is the initial velocity in meter per second, V is final velocity also in meter per second, and A is acceleration in meters per second. And finally, T is time in second. Now, it's important to remember that the first four quantities are all factors, so for them, direction has to be taken into account. I'll say more about this after going through the derivations. Here's the first. We'll start with an equation we already know from the previous chapter, which is A equal to V minus U over T, and arrange it to give the new equations V equal to U plus AT. It's a good idea to practice writing down these derivations yourself. So, in the first line, you'd write A equal to V minus U over T. Eventually, we want to get V to be the subject of the equations, but we can do that all in one step. We'll start here. So, in the second line, we have V minus U equal to AT. If we add U to each side, we get V equal to AT plus U. So, we can just rearrange the right-hand side to give us the equations we're looking for. As I said, try writing out derivations with each step on a new line until you've memorized them. Here's the second one. This one involves a velocity time graph. It is shown that the displacement can be calculated by finding the area under the graph. We'll use this to derive the equations as equal to ut plus half at squared. Imagine an object accelerating uniformly from initial velocity u to final velocity v in time t seconds. The displacement s is found from the area under the graph. So, firstly, we have this section, a rectangle. Its area can be found by multiplying its height by its length, giving us ut. The second section is a triangle. Its area is equal to half times the height times the length. The height of the triangle is vu and its length is just t. So its area is half times v minus u times t. If we remember back to the last derivation, at one stage we had v minus u equal to at, so we can substitute into the brackets. If we now multiply all the brackets, we can get equations hereafter. The third derivation, we start with the first equations and end with this. V squared is equal to u squared plus 2as. We start by squaring both sides, which gives us this. We then want to multiply out the brackets. There's more than one way of doing this, but we should end up with v squared is equal to u squared plus 2uat plus a squared t squared. Obviously, you will want to try this yourself. The left-hand side of the equations looks fine, but this part needs more work. What we do is take out 2a from this part of the equation, leaving the rest in brackets. Dividing 2uat by 2a gives us ut. If we divide a squared, t squared by a, we would get at squared. So, dividing by 2a would give half at squared. So, the right-hand side of the equations can be written like this. Go over this step again if you are not too sure. Now, remember that our second equation was s equal to ut plus half at squared. So, the term in brackets can be replaced by the letter s, giving us our third equation. The last derivation is the simplest. We start with these two equations. The first says that the displacement is equal to average velocity times time. And the second is an equation for average velocity, which is half u plus v. We then end up with this as equal to half times u plus v times t. All we have to do is substitute the second equation into this position in the first line. That is how to derive the kinematics equations. I do hope you understand about the explanations. We are going to have the sample work by our Zoom session and also from our WhatsApp session. Okay, thank you for your attention and bye-bye.